Hello, this is Barry Walsh, your COVID-19 Math 10 teacher online. Today we're going to do equations of parallel and perpendicular lines. Last class we did slopes, parallel and perpendicular. Today, equations of the same. Now hopefully you remember that when lines are parallel, how are the slopes related? The slopes are the same or equal. And when we have perpendicular lines, I hope I have enough room here. Perpendicular lines, the slopes are negative. Do you remember? Negative reciprocals. Reciprocals, C-A-L-S. Now, what is a negative reciprocal? Remember something like 2 over 3? If 2 over 3 is your slope, I can squeeze it in up here. 2 over 3, what is the slope of a perpendicular line? Minus 3 over 2. So what you have to do is flip the fraction over and change the sign. Don't forget to change the sign. Okay, we're going to start today with slope point form. Slope point form is often an easy way to do this, but it's not written in stone. Sometimes you have to use slope-intercept form. Now this first question starts off by giving us slope-intercept form. It says, write the equation of a line that passes through 2 minus 4 and is parallel to y equals 2 over 5x minus 3. So if we use slope point form, do you remember? Equals m times x minus x1. And x1, x2 is always the point that you're working with. I meant to say x1, y1. Sorry about that. So this x1 and y1 is always the point that you're given to work with. Now because this is a parallel question, here we go, keyword, the slope of the line is going to be the same as the original equation, and it has to pass through 2 minus 4. Now the x number, the number that goes with x, will be 2. The number that goes with y, now it's a negative, so on my first writing here, I like to show all my steps. In my first line, I've got double signs, and I don't want to leave it there as a double sign, so I'm going to change it to y plus 4 equals 2 over 5, that's the slope, and x minus 2. So that's all there is to it. That's it for the first question. 1a. Now with 1b, it's basically the same question, but instead of a parallel line, we're going to find a line that is perpendicular to this one. We're using the same point, 2, negative 4. So I'm going to start off the same way. Y, take away y1 equals m times x minus x1. So this time, it's perpendicular. And remember up here, our quick review at the beginning of the lesson today. This slope is 2 over 5, and if we're looking for a perpendicular line, we have to get the negative reciprocal, which would be minus 5 over 2. Now everything else with the x is going to be the same as it is in this question because the point is the same. It's going to be x minus 2, and I'm not going to write this twice. I wrote it twice up here with the double negative. I'm just going to write y plus 4 here. Just take a bit of a shortcut because you've already seen what happens with the double negative. And it's very similar answer, isn't it? Except for the slope is the negative reciprocal. And that's 1b. Now number 2 says, write an equation for a line that has a y-intercept of 6 and is parallel, there's our key word, parallel to y equals 3 over 4x plus 7. Now one thing you have to remember is that when you're given a y-intercept as a single digit, you have to consider that it is an ordered pair, and that would be 0, 6. Okay, so once again, y minus y1 is equal to m times x minus x1. Okay, so it's a parallel line, so the slope has to be the same as the slope given in the question. So the slope will be 3 over 4. And now we're only given 0, 6 here. We only need 1 point. So it'll be x minus 0 and then y minus 6 over here. I don't like leaving the 0 there, and I think your teacher, your own teacher, is going to tell you not to write the 0. I suspect that's supposed to be a 3 over 4, and I'll just put the x there. Now when there's no number written with the x, it's understood that it's 0. So you can look at this equation as it's written now and say, yes, the point is 0, 6. Because there's no number written, you understand that it is 0. And that's the answer for 2a. Now, 2b. I didn't like the way it was written when I first saw the question, so I rewrote it. Hopefully, it's a little bit better to understand. So we have a first line that has an x-intercept of 2 and a y-intercept of 4. So these are single-digit points. So to make it a little bit easier, I'm going to write them as minus 2, 0, because that's the x-intercept, and the y-intercept is going to be 0, 4. The second line is perpendicular to the first and passes through minus 3, minus 2. What is line 2? Well, the first thing we need is a slope, and we're not given an equation. Now in the previous 3 parts, up here we were given a slope. In 1b we were given a slope. In 1a we were given a slope. Here there's no slope given as part of an equation. So what we have to do is calculate it. To get the slope, you need 2 points, correct? x1, y1, x2, y2. So I'm going to squeeze it in here. M is equal to y2 minus y1. That would be 4 take away 0 over 0 subtract negative 2. And 0 subtract negative 2 is just going to be 2, because that'll be a 0 plus 2, and then when you divide, we get a nice even number. 2 is the slope. So when you're not given an equation with the slope in it, you're going to have to get the slope some other way. And this is how we do it in this particular problem. So again, and once we have the slope, y minus y1 equals m x minus x1. And what are we doing here? Perpendicular. I often have to go back just to make sure, because if you aren't thinking clearly or reading it twice, you might make the mistake of doing a parallel question and then you get it wrong just because you were careless and not reading it carefully. So if it's perpendicular, the slope will be negative 1/2. Does that look good? And it's going to be x minus and y minus. Now the x value is negative 3. The y value is negative 2. And I don't like the double sign, so I'm going to clean that up. Y plus 2 equals negative 1/2 x plus 3. And that's it for question 1 and 2. I'll be right back. Okay, let's look at question 3. And this is the last question for today. Two perpendicular lines intersect on the y-axis. The equation of one line is y plus 9 equals 2 over 3, bracket x plus 3. What is the equation of the other line? Okay, let's bring this down here. And I'm going to bring this down again over here because I want to show you something. Now we have to make a line perpendicular to this one, but they both have to have the same y-intercept. That's what it means when it says the lines have to intersect. They have to be perpendicular and they have to intersect on the y-axis. Now this is a different kind of problem. I want to show you something. Now we can make a perpendicular to this one over here by changing the slope. This is not the answer to the question. This is one line that is perpendicular to the line. We have the equation of the line here, and these two, the one that we changed to minus 3 over 2 is the slope. It would be perpendicular to this one, but it will not have the same y-intercept. So we have to change it to slope-intercept form. That's what I'm going to do with this one. Get the y-intercept, and then we can change this one over here. So I'm going to cross this out and just say that this is not what we're after in this case. Okay, so let's change this to slope-intercept form. 2 over 3 times x is 2 over 3x. 2 over 3 times 3, this is like 3 over 1, right? So 2 times 3 is 6. Top by top, 2 times 3 is 6. And on the bottom, 3 times 1 is 3. And we have y plus 9. Now this simplifies to 2 over 3x plus 2. And now we want to get the y by itself on the left side of the equation. So I'm going to say y plus 9 minus 9, opposite operation. If you subtract 9 from the left side, you have to subtract it from the right side. These cancel out, and we get y equals 2 over 3x, subtract 7. 2 plus 2 and minus 9 is minus 7. Now, what we see here is that the y-intercept, this is the y-intercept, and to take that a step further, if these lines intersect on the y-axis, that means they both have to have the same y-intercept. You understand what I mean? So if you were making a graph, the two lines would cross on the y-axis at minus 7. Now, the easiest way to give the answer to this question is to give the negative reciprocal of the slope, because we know it's a perpendicular line. The negative reciprocal is minus 3 over 2 for the slope, x, and then the y-intercept is the same, so we have that. So here is the answer over here. That's the easiest way to do this one. The easiest way often is with slope point form, but in this particular question, you could put it in slope point form, but it would be more work. Okay, that's today's lesson. There are problems in the book. These are in section 6.5, page 373. They go along with slope point form. There's separation of the parallel and perpendicular lines in the book. And we did the slope questions last day, and today we're doing the equation questions. So on page 373, you can do 20, 21, 23, 24, let's see, 25, yes, and 25. Those are good questions to practice on. This is not a real heavy lesson. As usual, be patient with yourselves. Work hard. Don't be distracted. Don't try to go too fast. I know you'll find this relatively easy compared to many things that you've had to do so far this year. You guys have a great weekend, and we'll talk to you soon. Don't forget, Barry Walsh, all one word, at gmail.com. If you get stuck, and I can give you live help right from the table I'm working on, if you get stuck or if you have a question. Perfectly natural to have questions.